Former NASA Administrator Jim Bridenstine, or Steen, excuse me, sir, is joining us this morning. Also with us today, the director of the Institute for Theory and Computation at Harvard University, Professor Avi Loeb. Gentlemen, good to see you both.
Thanks for having us.
Jim, the Artemis II crew getting ready for this lunar flyby. It's going to happen about 1 o'clock Eastern time. This is the furthest humans have traveled from Earth, surpassing the Apollo 13 record more than 50 years ago, of course. NASA's Artemis program, the lead, explains just how far they'll reach. Listen to this.
And then to come in for that translunar injection, we came all the way back to Earth again. We were out there at 60,000 kilometers. We came back to within 200 kilometers of the planet. And it just felt like we were falling out of the sky back to Earth. And I said to Reed, it feels like we're going to hit it. It's amazing that we're actually going to go around and miss this thing.
But they didn't. They didn't. They took off once again. But boy, so close to home, right? How incredible, historic is this achievement? Jim, let's start with you.
So it's obviously, this is tonight is what it's all about. Obviously, we have the launch, which is super exciting. We're going to have the entry, descent, and landing, which is also exciting. But the mission is really about going to the moon, and tonight we go to the moon. The astronauts tonight, they're going to see an Earth set, and they're going to see an Earth rise. At the same time, while they're behind the moon, it's going to be a blackout. They're not going to have a signal. And so that means for a period of 40 minutes, our astronauts are not going to be able to communicate back to the Earth. But in that time, records are going to be broken. They're going to fly closer to the moon than at any point on this journey. And at the same time, they're closest to the moon. They're going to be further from the Earth than any humans in the history of the Earth, which is just a magnificent achievement. So there's so many different things that are going to happen tonight. This is what it's all about.
So we're super. Go ahead and finish your thought.
Oh, we're super excited about it.
Absolutely, we are. Dr. Loeb, let me bring you into the conversation. Tell me, what are they're going to have to work fast. As Jim just laid out, there is a lot of things happening simultaneously, and the window is short. What are they trying to capture, and how significant is it?
Well, this is a very exciting day, one day after rising to the moon on Easter. The astronauts will observe the moon's far side from about 4,000 to 6,000 miles away, viewing never-seen-before terrain, including craters, frozen rock flows, and massive basins. And they will document high-elevation craters, ancient volcanic structures, potential meteorite impact flashes. Altogether, it would be also exciting for understanding the moon. But all in all, this is the first step coming close to the moon. The next step is combining such a mission with the lander and ultimately establishing a base on the moon with a nuclear reactor, with scientific infrastructure. And frankly, I will be delighted to go on a one-way trip to the moon once the infrastructure is there.
Would you really? I don't know. I think I'd want to be able to come back. I don't know about you, Jim. But one way. Well, but that's what we're going for, right? That's kind of the plan, is to be able to, see what we can do to set up shop on the moon first. On board the Orion, Jim, the crew practiced putting on these pumpkin-colored pressure suits in case of emergencies. They did that in the last 24 hours here. What kind of situations could or would arise that would necessitate that?
Well, imagine if they were to hit like a micrometeoroid or something, and they lost pressure for a period of time. The capsule is designed to quickly create more pressure so that not all is lost. But at the same time, they'll need to quickly don their spacesuits, which of course are designed to be pressurized so that they'll have everything they need to survive and come home safely in their pressurized suits. So that's what that's all about. They're practicing now, and of course, you'll see them wear the suits on launch and on re-entry just in general, but they also practice around the moon. I would also say when we talk about this lunar base that we're going to build, our astronauts tonight are going to look down and they're going to see portions, small slivers of the south pole of the moon. That's where there's hundreds of millions of tons of water ice, which of course is not just water to drink. It's also oxygen to breathe, and it's hydrogen for fuel. And all that's present on the south pole of the moon. So they're looking for opportunities for the future to land and build that lunar base.
Wow. Let's talk about that, Professor, a little bit further. That you were talking about the plan, the stages. Artemis III would then launch and test rovers, if I'm understanding that correctly, and then perhaps, get maybe boots back to the moon again with Artemis IV. Is this what the plan is, and are we on track?
Yes, but it's a very different plan than the Apollo missions in the sense that the idea is to establish a base, establish the superiority of the United States technology and science in leading humanity into space. And that means putting also scientific infrastructure there. There are various proposals for taking advantage of the lack of an atmosphere on the moon, the lack of any seismic noise from earthquakes and so forth. And altogether, it's an amazing opportunity as a first step towards Mars. Eventually, we might go to Mars. These are two rocks that happen to be closest to Earth that nature gave us an opportunity to land on. But ultimately, the way I see it is the initial steps towards establishing a space platform that carries humans or robots with AI out of the solar system. The Milky Way is a far greater landscape. There is much more real estate out there, and it's for humanity to take.
It is extraordinary to think about when you lay it out like that, and the incredible opportunity. Jim, I know that NASA, they had they scrapped a planned trajectory correction over the weekend. What was that about? And does it mean that they're back on course and there's no longer any sort of threat? And was there ever a threat?
Oh, no, they just hit the numbers so perfectly. They didn't have to actually do a course correction, it's remarkable. What that means is that the systems are working. They're working exactly how they're supposed to work, and they didn't need a course correction. So all of that, I think, is very, very positive news. It actually is good for saving fuel. For future missions, we can have even better confidence on how our systems operate and the data that we're able to collect and utilize in these missions. I would say Artemis III, just to be clear, Artemis III is going to be a mission to Earth orbit, where the Orion crew capsule is going to interact in Earth orbit with a landing system for the moon. And then 4 and 5 are intended to be moon landings. So there's a rapid sequence of events that's going to happen here, and it's going to require all of America to get behind us to move as quickly as possible, because the goal is, in fact, to not just orbit the moon, but land on the moon before China and start operating a lunar base on the South Pole.
It has been really exciting to see new life, really back in NASA's lungs, and then the partnership that has also occurred with private industry. Final thoughts, Dr. Loeb. We have a few seconds left.
Yeah, so clearly the technology that is being employed right now is far better than back in the 60s and 70s. For example, about 38 gigabytes are transmitted per day, data. That's why we see such beautiful images. So this laser communication will be very useful in the future for quantum computing and communication infrastructure. So there are lots of advances being used on this mission, and we should all salute NASA for doing such a fantastic job.
It's been fun to watch, and much more to come, and it'll be an exciting day, I know, for the two of you and the entire world. Former NASA Administrator Jim Bridenstine, Director of the Institute for Theory and Computation at Harvard University, Professor Avi Loeb. Gentlemen, thanks so much. Had a great conversation with you last week when I sat in on another show, and I asked our team to bring you both back. It's really wonderful to have you on the morning with us. Appreciate your time.
Always.